Because first of all, then everyone, even outside the industry, truly understands how mind-blowingly big breakthrough it is what we are bringing to the market, and what it can mean to the entire industry and even to our planet.
The first independent test results for Donut Lab's highly controversial solid-state battery have finally been released, confirming one of the company's most attention-grabbing claims, while simultaneously exposing its most critical weakness. The cell can indeed be charged from 0 to 80% in just 4.5 minutes at an extreme 11C rate. It did not explode, short-circuit, or suffer immediate catastrophic failure. However, the data makes one thing equally clear. Charging at this speed produces enormous heat, pushing the battery dangerously close to thermal limits when cooling is even slightly constrained. The testing was conducted by VTT, Finland's state-owned technical research center, and one of Europe's most reputable independent research institutions. The credibility of the testing body is not in doubt. The scope of the report, however, is narrow. VTT verified only fast-charging behavior. None of the battery's most ambitious claims, energy density, cycle life, temperature resilience, or cost parity with lithium-ion, were examined or validated. As a result, the report confirms a single technical capability while leaving the broader narrative unresolved. According to the official report, researchers tested a single 26 ampere-hour Donut Lab solid-state cell using a PEC Act 0550 battery testing system inside a climate-controlled chamber. The charging protocol followed a standard constant current, constant voltage profile with an upper cutoff voltage of 4.3 volts. This methodology aligns with industry norms and minimizes the risk of artificially inflating performance through unconventional testing techniques. The cell was charged at two aggressive rates, 5C 130 amperes and 11C 286 amperes. Before and after each fast-charging session, the battery was discharged at a conservative 1C rate down to 2.7 volts to verify usable capacity. This step was critical in confirming that extreme charging did not immediately compromise voltage stability or accessible capacity. From a purely electrical standpoint, the results are impressive. At 11C with two heat sinks attached, the cell reached 80% state of charge in just 4.5 minutes. During this process, surface temperature rose from 26.5 degrees Celsius to approximately 63 degrees Celsius. At a 5C rate, thermal behavior depended heavily on cooling configuration. With a single heatsink, the battery heated from 27 degrees Celsius to around 61.5 degrees Celsius. With two heatsinks, peak temperature was limited to 47 degrees Celsius from a starting point of 23.4 degrees Celsius. These results demonstrate that the cell can survive extremely aggressive charging without immediate electrical or structural failure. That alone is a meaningful technical achievement, especially under conservative safety protocols. However, the most important insight does not come from the best-case configuration, but from the scenario that most closely resembles minimal real-world thermal management. During the 11C test using only a single heatsink, surface temperature rose rapidly and reached 90 degrees Celsius, triggering VTT's safety threshold and forcing the test to be halted. This intervention was not a failure of the cell itself, but a precaution to avoid potential thermal damage or runaway. After a brief coolings period, researchers improved the mechanical contact between the cell and the heatsink to enhance thermal coupling, and the test was resumed. This 90 degrees Celsius event is arguably the most significant finding in the entire report. Donut Lab has consistently implied that its solid-state battery does not require active cooling. Yet under the very conditions used to demonstrate its advantage, passive cooling proved insufficient. The battery crossed into a temperature range that would be unacceptable for sustained operation in any production electric vehicle. This does not mean the battery is inherently unsafe, nor does it invalidate the achievement of fast charging. It does, however, indicate that repeated or continuous 11C charging would almost certainly require additional thermal engineering, active cooling, advanced heat spreaders, or improved thermal interfaces would be necessary. While this requirement is common in high-performance battery systems, it directly contradicts the implication that extreme charging speeds can be achieved without meaningful thermal constraints. Crucially, The VTT report does not address the claims that have generated the most skepticism across the battery industry. Energy density remains entirely unverified. Donut Lab has claimed a gravimetric energy density of 400 watt-hours per kilogram, a figure widely criticized as physically implausible when combined with ultra-fast charging and extreme cycle life. The chairman of Svolt Energy has publicly stated that such a combination contradicts fundamental battery chemistry. For comparison, solid-state cells developed by Factorial Energy and independently validated by Stellantis have achieved around 375 watt-hours per kilogram. Even at that level, these batteries do not claim 11C charging or extraordinary cycle life. Other manufacturers may advertise higher energy density figures, but none attempt to combine all of these extremes within a single, independently validated design. The claim of 100,000 charge cycles is even more disruptive. Most solid-state battery developers today target lifetimes measured in hundreds or, at most, a few thousand cycles. Factorial's validated cells demonstrate just over 600 cycles. A jump to 100,000 cycles would require a fundamental redefinition of degradation mechanisms at the electrode-electrolyte interface. The VTT report offers no evidence supporting or refuting this claim. Independent validation of extreme temperature performance is also absent. Donut Lab has stated that its battery retains nearly full capacity at -30 degrees Celsius and remains stable above 100 degrees Celsius. No low-temperature impedance data, extended heat exposure tests, or thermal cycling results are included in the report, leaving these assertions unverified. Cost parity with lithium-ion batteries lies entirely outside the scope of laboratory testing, yet remains one of the most controversial claims. To date, no solid-state battery developer has demonstrated cost competitiveness at scale, largely due to materials complexity and manufacturing yield challenges. The skepticism surrounding Donut Lab did not emerge in isolation. When the company unveiled its battery at CES, it offered no live demonstration, no patent disclosures, and no peer-reviewed research. Industry reaction was swift. Donut Lab's CEO later responded via Electrek, stating that he was staking his personal reputation on the technology and that customer motorcycles from Verge would soon adopt the battery. Commissioning VTT was therefore a necessary credibility reset, but not a comprehensive validation.